Okay, so we are going to start talking about inverse functions today. I'm sure we will not finish or even come close today, but that's all right. So what I have given to you all is a little note sheet here. All right, so let's read through this together. There are a few things that we're going to want to add. So let's read inverse functions. By the way, before I forget, this is the last section that we do in this unit. Yep. So there will be, I don't have it scheduled out just yet because I'm not quite sure how long inverse is going to take us. Either 2 days, maybe 3 days. So, but we.
Wait, a test Friday?
No, it was a joke.
Oh, you guys. So yeah, inverse functions will probably take us 1 or 2 days. We'll see. We are going to have a quiz on just inverse functions whenever we do finish it. So that would be early next week. And then we will review for the unit test and then take the unit test. So the unit test will be sometime next week. I just don't know when. My best guess would be Wednesday of next week. Yes, but because you guys don't have school on Thursday. So if it's not Wednesday, then it'd be Friday.
Oh,
Yes. Hey, yeah, what? What's up?
we're not gonna be good Thursday.
Tuesday.
Like, what?
I'm gonna miss it. I just saw an email. Do you know that there's 5 Graces on that list?
Yep.
I couldn't believe it. I'm
I
like, it's
could've
great,
been on
it's
that
great,
list,
it's
but
great, it's great. Yeah, okay.
What? Oh, I was already in it. I was just scared about it.
Why?
I don't like it.
Oh, dear.
Wow.
I despise him so.
Oh, my.
I thought you were already in it, like.
I what?
You quit?
Yeah. Well, why did you come back?
What do you even do?
You don't talk the health classes about being a better person.
Do we get to choose our groups?
I have my.
Choose our groups?
Should I do math?
Yes.
Okay, well, I just wanted to let you know.
Well, thank you. I saw the email, but I didn't realize what date it, I saw the date, but it didn't click. So, well, whatever you miss, you miss.
Okay, pretty smart.
Oh, Lord.
All right. So anyway, next week, when you have a quiz on inverse functions, you're not all going to be shocked and say, what are you talking about? And now you know that this is the last section of the unit. So the unit test will be right after that. Okay? Okay.
Are you saying like that Friday?
Right. I'm thinking that the test could be Wednesday, the 10th, 11/10 for the test.
Oh. Okay.
So yeah, I'm thinking the quiz may be Monday. It depends how long it takes us.
Don't do that.
But it'd be like, just like today, like I would be not one that takes the whole block.
Well, let's see how this.
Yes, let's see how this goes. All righty, everybody, you with me? So 3 things you'll need to be able to do with inverse functions. Are you listening? No, you're not. Okay, here we go. So first, we're going to determine if a function has an inverse and find that inverse algebraically. So that's kind of what we're going to look at today. Eventually, we will be able to sketch a function and its inverse and find their domain and range. And lastly, I'll give you 2 functions and I'll ask you, hey, are these inverses of each other, yes or no? So these are sort of our goals for inverses moving forward. All right, so first thing we're going to do is try and figure out if a function even has an inverse and how do you find it? So what are inverses? It's basically, the easiest way to think about it is to look at a graph. If you have a graph of some function and you reflect it over the line y equals x, which is that perfect diagonal, if you reflect the graph over that line, you have created its inverse. Now, Think about a parabola. If you take a parabola and you flip it over that line, it's no longer a function anymore, is it? Right? Because you went from a U shape and now it's going to flip over and kind of be like a C shape. So now it's not going to pass the vertical line test. So what we can do is we can do, if you look at the very first bullet, it says, does the function pass the horizontal line test? So if you know the general shape of your function, so if it's a parabola does not pass the horizontal line test. So I pass a horizontal line through it, and if it ever hits more than once, that means if I take the inverse of that thing, it's not going to be a function. Isn't that interesting? Okay, so that's what the horizontal line test is. So in fact, I'm just going to add, if it fails, the inverse would not be a function. So sometimes what we do to ensure that it will be a function, sometimes we restrict the domain. So we'll talk about that when we eventually get to example letter D down at the bottom there. Okay, so how do I find an inverse if I don't have a graph? All you have to do is you're literally going to swap X and Y. Because if you think about it, if I'm reflecting the graph over the line Y equals X, they're equal to each other. So I can swap X and Y with each other. So we are literally going to swap the two values. I'm going to then solve my new equation for Y. And I'm going to just replace Y with, this is the inverse notation. See that? F, and then there's a little tiny -1 up there of X. That notation is how we write inverse of F. Inverse of F. Okay. There is one more bullet that I want you to add, and that just ties in with when we do restrict the domain. So we'll talk more about it in a few minutes, but if you want to add it right now, we're going to revise our inverse function if needed to ensure outputs correspond to the restricted domain of the original. Thank you. So go ahead and just jot that down for now, and then I will explain what in the world I am talking about when we get down there. Try turning this on. That usually helps. That's better. Okay, everybody added that extra bullet on? Okay. So let's walk ourselves through one of these examples. So the first one we have here, g of x is equal to 2 times x plus 1 cubed. So think about what that graph looks like. If you have an x cubed graph, what do those kind of look like? Everybody remember just a general shape? Yeah.
It's kind of looks like an S.
Yes, they're kind of, I'll stick it over here. They kind of go like that. Right? So if I pass a horizontal line through that thing, it never hits more than once. Right? You see that? So this thing will pass a vertical and a horizontal line test. So that just means when I go ahead to find my inverse, I know that the inverse is going to be a function. All right, cool. So what do I do to actually find it? I'm literally going to take x and y and switch them. Remember that g of x is just y. So that thing is just a y. So when I swap these two, this is what it's going to look like. Oh, don't break your pencil. I write x equals 2, open parenthesis, y plus 1 cubed, like that. So there's the first step. Nice and easy. I literally just write X when I see Y and Y when I see X. My next step now is to just solve for Y. So what would you do next to get Y by itself? Cedric? Yes, let's get that 2 over to the other side. And now what are we going to do? Evan?
Cube 1 plus 1.
Cube root, yep. So I want to undo that cube, so I'm going to take a cube root of U and a cube root of U. So now I've got the cube root of X over 2 equals just Y plus 1. And I'm almost there. All I have to do is Evan.
Subtract 1 from the side.
That's it. Just minus that 1 over to the other side. So now I've got the cube root of X over 2 minus 1 is equal to Y. Okay, so we've done that second bullet up here. The third one says, hey, now that you have it, you're just, instead of writing Y, we're going to replace it with this function notation. So I want, and I also like it to be on the left-hand side instead of the right. So I'm going to finish it out by saying f of -1 of X is cube root of X over 2 minus 1. So the inverse function of f is equal to the cube root of X over 2 minus 1. We don't have to worry about the last bullet here because my original domain wasn't restricted. I didn't have any issues there. You'll have an issue. Take a look at letter D. See how it says, first of all, we might as well do this right now. It's a typo. It should not say X is greater than or equal to -2. It should be +2. So can you change that to a +2 on your note sheet right now? So this one, this one had a restriction on my domain. So that's where that last bullet comes into play. So right now for letter A that we're doing, I'm done. That's all I have to do. Yep.
For A?
Yep.
You have to write that for senior rating.
Oh, it should have been G. Good catch. Yeah, because our original was G. So we're doing the inverse of G, not actually F. Good catch. Okay, so let's try B. So go ahead, give it a shot before I show you how to do it. Swap your X and Y, and then see if you can get Y by itself. How did we do? Did we get somewhere? Or did you get a couple steps in and then you're like, I don't know how to do this part? Let's see, I'm gonna work through it together. So I've already swapped my X and Y, so hopefully you did that too. And then the next step, I should just so I want to get the Y by itself. So in order to do that, I should, you're on this one, right?
Oh, I was thinking D.
Oh, yeah, not yet. Don't do D yet.
I heard you talking about it. So.
I know. I would add 2 to the other side, right? let's add the 2. So I've got x plus 2 equals 3 over y minus 1. So now I'm curious to hear what you guys did to get y by itself now. Jake, what'd you do?
Multiply both sides by.
You can. It's not wrong to do that, but I don't think it's not gonna help me get closer. I want y, you're getting rid of the 3, but not really anything else. Evan, what'd you do?
I multiply both sides by 1.
There's the thought. So if you multiply both sides by y minus 1, at least that gets the y out of the denominator, right? So there's a possibility. So if you multiply by y minus 1 on both sides, these will cancel. So now you're here. You have y minus 1 times x plus 2 is equal to 3. And now I'm almost there. Because what could you do now? Evan, what'd you do from here?
I divide both sides by 1.
Yes. So I can divide now by x plus 2. So those cancel. And now I'm going to keep going over here. I'm at y minus 1 equals 3 over x plus 2. And then all I have left to do is add the 1, right? And then the only thing left to do is to just put it in the inverse function notation. So my original was f, so I'll have I'll be there. So what's so cool about this, and what we'll see tomorrow, is if you graphed this thing and you graph the original, they'd mirror each other over that line y equals x. So cool. Just wait. Just you wait. Okay, try C real quick. Well, hold on. Was there any questions on this one? Is that all right with everybody? See how we did that? Okay, so let's try C. I'll do it too, and we'll just see if we match at the end. Careful who's under the root and who's not. How did we do? Does yours match mine? Watch that negative there, right? When you are getting the y to be positive, you got to divide both of these by -1. So I have the negative for this term, and then my positive 4 terms negative. Yeah.
Did you square both sides before you back to the five?
Yeah, so like you did it out. Did you like do x squared minus 10x plus 25. Is that what you mean?
That's what I did.
Yeah.
Yeah, you can do that. And it should, now if, so it, we should all come up with something equivalent at the end. So let me do it out and let's just see if we match. So if you multiply that out, that's going to be a negative x squared plus 10x minus 25 minus 29. Is that what you got? Katie, is that what you got?
Yeah.
The minus 29? Yeah. Either one should be fine, because they should be equivalent. Okay, so now let's talk about this last one here. All right, so if you think about this parent function here, that's a quadratic, right? So if I graph that, that's going to be parabola. If you flip a parabola over, you're going to start with a parabola shape, but now it's going to be a C shape. Now it's not a function anymore. So what we've done here is we've restricted the domain of it. So if you were to graph this, instead of seeing the whole thing, let's see, I'd be up 3 to the right 2, right? So it'd be something like this. So what we're doing is we're saying, hey, we're only going to look at the values when x is greater than or equal to 2. So we are ignoring that piece of it. So if I took just that piece and I flipped it, that's going to be fine. That would still be a function. So the only thing that you have to do differently is you're still going to solve it just like you normally would. But when you get to your final answer, we may have to adjust it. So let's go through it. So go ahead and try it. Swap your x and y. I already kind of did it out, but you do it. Swap your x and y, solve the y, and let's see. Let's see if you all get to the same spot as algebra. Okay, did you get to where I got so far? Swap your x and y. I'm gonna minus the 3 over, square root both sides. When I take a square root, I have 2 roots, right? And then I just added the 2 over. So now I'm here. Is that part okay with everybody? Before I talk about this weird part? Okay, so if we look at that 4th bullet that we added in, our original domain was restricted. So we need to look at our inverse function to make sure that our outputs correspond to the restricted domain of the original. So remember what we did. We swapped x and y. So this is really x in the original, right? So x has to be greater than or equal to 2. Well, look at what's, if I allow both of these roots to be in there, wouldn't I get values? I want it 2 plus 0 or anything else is going to get me something bigger, greater than or equal to 2. So that's fine. To take the positive root is no problem because that will get me x's that are greater than or equal to 2. The problem is if I allow this negative root to stay in there, right? Let's say that this chunk came out to be, I don't know, 1. 2 minus 1 now gets me an x value that is not in my domain, the restricted domain of the original. I need x's to be greater than or equal to 2. If I already have 2, I can't subtract things from it. That would get me an x value that's not greater than or equal to 2. So I'm actually going to have to kick out the negative root. So I'm going to revise it to just be plus. This is so much easier to see when you graph it, because if you don't do that, you'll see that they don't match up. You wouldn't have a nice they wouldn't reflect over that. You'd have like half a parabola and then like a full parabola, and that would make sense. Okay, so I think these will be, I know it's a little weird right now, but once we do the graphing, I think that'll help a lot. So we'll do that part tomorrow. Okay, but does that kind of make sense why we can't have both roots in this case? Because it's not going to fit into my restricted domain that I had before. Okay, so please do not lose this note sheet because we're going to continue on it. But let me give you your homework for tonight. We are just going to do numbers 1 through 4 on this page. 1 through 4.
Stuffs.
Yay! Okay.